Welcome back to everyone. Next up, we have Rivada Space Networks is deploying and operating the first truly global low latency point-to-point connectivity network of LEO satellites. By connecting all of its satellites with lasers, Rivada Space Networks will provide resellers with B2B customers with the ability to securely connect any 2 points on the globe with low latency and high bandwidth. Pleased to present the CEO today, Declan Ganley. Welcome, Declan. How are you doing today?
Very well, Anna. Thank you very much. Greetings from County Galway in the west of Ireland, which is where I am today.
Yes, and a sunny day at that. So congratulations for your beautiful day.
Yes, yeah, they're not as frequent here as they might be in some parts of the United States.
Right, right. Well, let's talk a little bit about Rivada's constellation and how it's different from other LEO constellations under development.
Sure. So Rivada is doing something that's quite revolutionary. And I know people, there isn't an entrepreneur that doesn't think what they're doing is revolutionary, but this very much is. We're creating the outer net, distinct and separate from the internet. So this is a global network that envelops the whole planet in 24 orbital planes at 1,050 kilometer orbits. So these are very good orbits in polar orbital planes. And when you have polar orbital planes, it means you get to cover every square meter of the surface of the planet when you've got 12 or 24 of them, which we do in our case. In each of those polar orbital planes, we've got 25 satellites. Each one of those satellites is connected with a minimum of 4 laser connections to adjacent satellites in the constellation. So think about like a fishnet thrown across the whole planet, enveloping the whole planet, where the connections are laser connections, but they don't touch the internet. So they don't have to touch the internet unless they need to, meaning you go up to the satellite from the terminal and you stay on that space-based network until you get to your end destination where you come down. That's very different to traditional, I can now call them traditional constellations like Starlink or say the Kuiper design, where you go up to the satellite. And what the satellite is doing is looking for the closest ground relay station to land that traffic, which is then hauled across the normal terrestrial long-haul networks. We avoid all of that. We're putting 600 routers in space. That creates this mesh. It creates the outer net, and that's what Rivada is doing.
Yes, isn't it wild that we use the term traditional now, but it's true. And the fishnet reference helped my mind latch onto this concept. So let's talk about what made Rivada Networks, historically a terrestrial networking technology company, decide to get into space in the first place.
Well, we were really pioneers. Before it became fashionable, we were talking about shared spectrum when nobody knew what that was or what the concept behind it was. And the idea that Rivada had was that the way that we use radio spectrum is inefficient. A lot of it gets parked and is sort of basically sat on by spectrum squatters and is not put to use in the general economy. So we advocated for a long time, in fact, initially, sharing the spectrum held by public safety organizations, defense departments, that type of thing, where that spectrum's sitting there and not being used very often, but it could be used on a sub-priority access basis for commercial users, but with ruthless preemption for high-priority users. Very interestingly, the ITU, which is the international body, which is an adjunct of the United Nations now, which manages spectrum masses between all of the nations of the world, the ITU for satellite spectrum decided to use a shared spectrum model, meaning that these low Earth orbit satellite constellations are sharing the same spectrum, in our case, the Ka band spectrum. Now, for example, Ka band is also being used by Starlink, it's being used by Amazon Kuiper, and it's being used by a lot of other satellite operators, but it's done on a prioritization basis. Now, the way that the ITU does prioritization, it's a bit like a patent. first to file. In our case, Rivada saw an entity in Germany and an entity in Liechtenstein that had what we believed would become the #1 priority filing for the Ka band spectrum globally and the orbits that went with it. And we went and acquired that company and those assets. And that license has now been granted by the Liechtenstein regulator, and this is for global spectrum, directly to Rivada. Now, just to explain, why would Liechtenstein get to regulate global spectrum? A bit like a patent, it didn't matter what country you applied through. So, for example, Starlink's one of its first licenses is through Norway. Not many people know that. This was done through Liechtenstein because the Liechtenstein regulator had developed a field of expertise. But because Liechtenstein is an equal voting member of the United Nations, the same as the United States or Germany or China or Russia, it's got one vote. You can go through the Liechtenstein regulator. That's how this spectrum allocation was made. And in their case, the two filings that were above this have fallen away, meaning that this filing is now moving to the #1 slot globally. And what does that mean? It's kind of like being in boarding group 1 rather than boarding group 6 on a very full Boeing 747. You're much better off being in boarding group 1. The difference here is boarding group 1 gets to take as many seats as it needs before boarding group 2 can even start to board. So you're at the front of the queue. You have to be a good neighbor, but it's a great place to be. And that's why we went after that shared spectrum top priority right with the orbital rights that went with it.
So what lessons from terrestrial networking do you think Rivada brings to the satellite world?
Well, first of all, the value of spectrum. And this is, it's fascinating to me. I'm 54 years old now. And I've been in the wireless industry since I was 19 years old. And I remember the day back in the early 1990s and the late 1980s, when nobody knew how to value terrestrial spectrum. This was before the days of spectrum auctions and all of this stuff. And I remember in one case, a guy handing back a license for spectrum because he didn't want to pay a fee of like 80 grand at the time. That spectrum now is worth billions, the spectrum that he handed back. So spectrum is a finite resource. They're not making it anymore. There's one block of it. Well, there's more than one block, but in this case, for low Earth orbit satellite use, this Ka band is the premium priced block. And having the #1 slot to thousands of megahertz of Ka band spectrum is very valuable. The fact that the markets haven't figured this out yet is great, frankly, for us. They're figuring it out, and that penny's going to drop, I think, very, very soon. And in the same way that people realize the value of terrestrial spectrum, you can do more with satellite spectrum than you can with terrestrial spectrum. You can reach more places. The cost to do what we are doing from space, if you're going to try and do it with the terrestrial network, it would probably cost trillions of dollars. To get that kind of coverage with that kind of capacity, that kind of speed, that kind of security. For a fraction of that amount of money, you can do this now and build the outer net with the technology that exists today in space in that spectrum.
Fascinating. So many have predicted a convergence between satellite and terrestrial connectivity in the past. So is it different this time?
No, that convergence is happening. You're starting to see it happen. So you saw the Global Star Apple announcement, and now you're seeing these rumors of Amazon Kuiper talking to Dish and all of this stuff. Everybody realizes that convergence has to come, especially in the world of the Internet of Things. So there's been a fixation in the past with everybody thinks of connectivity as this, right? That you're connecting to a cell phone. It's not about this. It's going to be it is about that a little bit, but for every one of these, there's going to be 250 or more other smart connected devices doing specific things for industry, for agriculture, financial services, healthcare, all public safety, defense, you name it. Those devices all need connectivity and they need ubiquity of coverage. And that's where this is all headed. And that ubiquity of coverage is going to require systems or devices to really not care whether they're getting their signal from a terrestrial system or from a space-based system. It's like whether you take a call today on your landline or your mobile is probably more reliable at this point. It doesn't make any difference, and it's not going to make any difference to the users of the future. That convergence is definitely happening, and Rivada is at the center of driving that.
So in the satellite world, Declan, unlike terrestrial wireless, all spectrum is shared spectrum, correct? So how important is priority really? Well, to the first part of your question, which is unlike the terrestrial world, the satellite world is shared spectrum. The answer to that is yes, you're absolutely right. And I would say that this is where the terrestrial world has a lot to learn from the satellite world. The reason that we have terrestrial spectrum allocation being done by the way it is not because it's the best way, it's because it's how it got done at the beginning. And so you have a lot of spectrum is wasted where it's allocated to the holder of that spectrum, but they don't use it very efficiently. Whereas for satellite spectrum, if you're not using spectrum efficiently, someone else is going to use it for you. And this is where the sliding... Now, if someone with priority is also a very efficient user of spectrum, it means that the ability for others to get in your way is they can't do it. For the priority, the holder of the high priority, it means you're not having to do mother may I to others. So priority gets to be, again, think about boarding group 1A, Diamond Plus, concierge service, whatever. That's what you are when you're in boarding group 1. You don't want to be in boarding group 6 if you can avoid it. It doesn't matter if there's 4 people on the plane, it doesn't matter, right? It's only when it's full that it really matters. But that's the same intersection where premium services are created, is where there's high demand. So the ability to generate premium service revenues and revenue streams priority is going to matter in those cases, I think. So we all know you're awaiting word from the RRB on your Milestone 1 waiver application. Has this affected the program with Terran?
No, is the short answer. And just for those viewing and listening, the RRB is the Radio Regulations Bureau of the ITU, which is an adjunct of the United Nations governing all of this global satellite spectrum. So the waiver is on the agenda, and this is the waiver allowing Rivada to start our launches, our main launches in April of 2025. And begin to launch our first 300 satellites for our full commercial network. We are very highly confident that we will get that waiver, and there's a process that's in place, a set of rules for this, how these things are granted, and as they apply to us, the requirement was that we had to be on contract with a satellite manufacturer for, in our case, the first 300 satellites, and that we had launch contracted with a credible launch provider, which in our case is SpaceX. And so we had those inked. Now, this wasn't an ITU requirement, but it was a requirement that the regulator in Liechtenstein put on us, was that they also wanted to see that we had equity commitments in place that we could get all of this done. And we provided those because otherwise the Liechtenstein regulator wouldn't have put that application. It's actually the country that applies for the waiver to the ITU. You apply to the regulator then applies to the ITU. So we put all of that in place before that application went in. There's a process for comments or objections to be raised. I am informed that that process closed on Monday, so a couple of days ago, and there were no objections raised. There were no comments submitted within that timeline. So we are, one doesn't want to be impolite or arrogant about this, but we're quietly confident that that's going ahead. And to the other part of your question, which is how has this affected us with Terran? The answer is not at all. We know we're getting this because of everything that we've done. So we've been barreling ahead with Terran Orbital to get everything done so that we get everything up there and on time and in accordance with schedule and with the plan.
Thank you for that. We have a question from Tony Castro. Tony wants you to talk about the history. You mentioned it a little bit in the beginning of our conversation, but how did you start this company? And specifically, what problem are you solving?
The problem, so the way we started the company is that, I come from the terrestrial wireless industry going way back, since the early days, frankly. I used to be the youngest guy in the room. Unfortunately, that stopped happening a long time ago. But we set up Rivada originally. There's a story here, and I won't take up too much of your listeners' time. One of my brother-in-laws was a New York firefighter, and his radio failed on 9/11, and he survived. He was one of two guys from his firehouse that survived that day. I was already doing a lot of wireless industry stuff in Europe. I had founded Broadnet, which I ended up selling to Comcast, and I'd done other things. And I'm looking at what had happened on 9/11 with the failure of public safety communications, and I'm like, what the hell? Why did this happen? So we started to look at it, and we set up Rivada, first of all, to address the public safety communications need in the United States. And in doing that, we saw how inefficient spectrum was being used for public safety networks and some other networks. And we invented technology, tiering prioritization of access, and to create ruthless preemption. The idea, that thinking then being that for public safety, that ruthless preemption would mean that when they needed, where they needed to get access to capacity, they would have it in an instant. But for the rest of the time where they weren't using that spectrum, it would be available to be used for commercial use. That was the origins, to answer that gentleman's question. But we moved on from there. If you look at Rivada's patent portfolio, we have a large number of patents covering all of these areas, and not just as applies to public safety, but right across the whole broad commercial spectrum. And we greatly grew out the vision since then. In terms of what problem are we solving, this is the problem that we're solving with Rivada Space Networks. The problem that we're solving is that there is a need for high security, very low latency, ubiquitous coverage around the whole planet. So to give an example, now one that people would talk about, a high frequency trading platform at the high end of the market. So you've got an office in New York City, and you want to connect to Singapore and Frankfurt and Johannesburg and Kuala Lumpur. The fastest connectivity that you will to do that, you need a low latency network, and you want something that's reliable and secure, and where you can get a service level agreement, not a best efforts, but a service level agreement, a guaranteed data rate. And those customers will pay a premium for that connectivity so that you are faster than anything else on the planet, including going through subsea cables or anything else. The additional security element, in addition to encryption and everything else, is that this is the outernet. This doesn't go through the internet. You're not going into exchanges being pulled into the public internet. You're not going over ground relay systems. You're not going through subsea cables. This network is a network of lasers. It's a light network in space, and data going through a laser is faster than data going through a fiber because of physics. And in low Earth orbit space, it's a near vacuum. It's the perfect environment, frankly, for these laser fibers, if you will. They're not fibers, it's pure light that increases speed. So speed, people pay here for speed, connectivity, service level agreements, not best efforts. Your cell phone is a best effort basis, which is why your phone calls drop as often as they do. If you had a service level agreement with your carrier operator and your calls drop, you wouldn't be paying for that. You wouldn't be paying anything like you pay for that level of service. So it's differentiated. The Outernet is separate and distinct from the internet. That speed, that ubiquity, that reliability is all something that the market will pay good money for. Furthermore, we have, now, these are not executed final prepaid contracts yet, but we have an order pipeline of MOUs running into the billions with an S of dollars already in place. That's how much demand there is for this. The customers, sophisticated enterprise customers, government customers, they know they need this. And right now, there is nowhere that they can get it, as in nowhere. It's not available, what we will be able to provide. So, yes, there's demand for consumer, best efforts, low Earth orbit satellite constellations. What we're talking about is distinct. It's separate from that. It can very much enhance those kind of services. It can even provide those kind of services, but it's much more.
Thank you for that answer. Question from Chris. He wants to know, when was the company launched and how much was invested?
The company, well, Rivada itself was launched in 2005, but we didn't actually move into we didn't take over these filings, and we didn't start Rivada Space Networks until that project really started a couple of years ago. We were watching these filings early on because the ITU's approach to shared spectrum, we love it. I mean, it was like when we see the world that way, the spectrum world that way. So in terms of how much money has been invested in the company, we have not made that public, but let me just say it's well north of $100 million. And it's about to make an exponential jump from that point again. So we have our existing shareholders, some of whom are known in the public domain and some of whom are not, and some new shareholders that are joining us who have more than adequate resources to do all of this, frankly. Should they want to do so, and there is huge appetite for what we are doing right now, and we're using, obviously, like as you would expect a blend of debt and equity, and the debt providers. Part of the debt that we're looking to is are the export credit providers and financiers, the likes of US Exim Bank and others like that. We would qualify for those sorts of debt financing. So we've been focusing on our equity. We're in a very strong equity position, and we are in negotiations with well-established debt providers for the debt elements of this as the project moves forward.
And Keith wants to know if the company is currently profitable, and if so, can you discuss the margins?
No, it isn't. And that's just so Keith understands. I took a decision a few years ago not to focus on near-term or short-term profits, and that's a very deliberate decision. If I was a public company, I would probably be taking a different view. I might take a different view. That's not been our focus. Our focus as a very quite tightly held private company, in which I'm a very substantial shareholder, very large shareholder, and founder shareholder, is to focus on getting the technology perfected, building the IP portfolio, getting the outer net built and deployed, turning it on. There are some other things that we're doing that we don't have time to talk about here today that are also very innovative and disruptive. And when you are doing things that big, you don't want that quarter-to-quarter focus on trying to be profitable. We're looking to build a $100 billion plus value company here eventually. It's not public. It's not a SPAC. It's none of those things. It's privately held. And so everything that we have done has been focused on creating long-term shareholder value, not a quarter-to-quarter measurement. And by the way, I think it's something that's missing in entrepreneurship over the last particularly 10 to 15 years. It needs to come back. We need to take a longer view, because when you take a longer view, you end up with better solutions and better outcomes.
Good point. And Leslie has a follow-up question. Since you are a private company, are you seeking investments? And if so, what's the exit strategy? And are you planning on going public?
I've been obviously asked this question a lot. I find the idea of going public at the right time compelling. I think it's potentially very attractive. I think, if we were to do that, we're probably looking at sort of the 24-month window, something like that, maybe a little bit shorter, maybe a little bit longer. I want to get the outer net deployed with the help of Terran Orbital and SpaceX and others. We want to get it up. We want to get it turned on. And once Rivada owns and has turned on the outer net, I think it will become very obvious very quickly what's there and the sort of value that ownership of the outer net provides. Are we the person that asked you the question asked you, are we raising money? We have been. In fact, we've just finished a round where existing shareholders and some new institutional shareholders have made commitments and are coming in. But we will probably be going out there in the future. I love the idea of publicly traded companies. There are vagaries that are attached to being public, like this quarter-to-quarter, those kind of things. The short-term focus is where I'm glad we're not being buffeted by short-termism, because it allows us to focus on getting the mission done. But there will be a time when taking Rivada public makes sense, and I look forward to leading this company into an IPO at the right time in the future.
And Marco Scottini wants you to tell us about Rivada's financing capacity, especially according to the Terran Orbital deal.
We will make every one of our payments to Terran on time. And as a company and with our shareholders, we are all committed to getting that done. We've done it, and we are going to continue to do it. And Terran Orbital, we are highly confident. And I should talk about Terran a bit here. We selected Terran as part of a very rigorous process run by Rivada Space Networks GmbH and our engineering and technical team and space team out of Germany, who are top in amongst the very leading figures in their field from around globally. These German engineers, and German engineers are very, very rigorous, as they're known for, and these guys are no exception to that rule. They looked at everybody. They talked to everybody. We got responses from a broad range of potential suppliers, and we selected Terran Orbital because the Germans were satisfied and won over that Terran can get the job that we need to get done on time and on budget. And so there were relationships. These wouldn't be people that would be known, but they sort of, but in the company, inside Terran, the technical chops to be able to execute and get this done, they've got really good people. And they've got the setup and the facilities, the approach, the dynamism, the engineering skills to get this done, and that's what satisfied us and made us choose Tehran. The decision was actually very easy. It wasn't even close.
Thank you for that answer. We have a question from Carol Bridges. She wants to know, who are your customers and what is the revenue model? Plus, how many revenue models are there?
So our customers, so there's a split of customers or a spread of customers. So it will range from governments for the stuff governments do, for secure, high-speed communications that governments need, say embassy to embassy, other things that governments do, public safety, other things, security, etc. Government communications, enterprise communications. So think the energy sector, oil and gas, power, the connectivity that these big enterprises need, where with the outer net, you will be able to, the amount of investment that you will need, rather than having to replicate the same brain of an operation, automated brain of an operation across 15 or 20 different parts of the planet. If you're a major, say, oil or gas producer, you'll be able to have one brain, if you will, but the cardiovascular system that doesn't touch the internet, but that makes all of those things connect and use that one processing center, will all be connected through this outernet, through Rivada's outernet. Another example would be agricultural. So, for example, we're in discussion with some of the big agricultural people with regard to connecting the very sophisticated machinery that is used now in farming and agriculture, the smart, very smart machinery, where they want direct connectivity back to central hubs. And something like 70% or more of agricultural land that's hugely valuable, producing areas, doesn't have connectivity. It doesn't have a terrestrial option. With this, you could create network to the farm, so a connected 5G, 6G network, where all of a sudden you've got a 5, 6G footprint across a whole agricultural area that's looped into the outer net and connected this way. That's going to allow things to happen economically and in agriculture that are currently not possible. And then right down to entrepreneurs in rural areas that might want to set up a little local carrier to serve their town or their village, where we will be able to provide that connectivity to make that possible in a way that's never been possible for communities like that before. And then there's going to be the building, the big landmark building, bank, whatever, that wants to be able to go straight to its sister building in a city that's 6,000 miles away and have a direct closed link that is an actual private network rather than a virtual private network, a real private network connecting those two buildings to each other, and everything in between. So there are different market segments. There's the premium users that have high value on low latency, on the very unparalleled level of security that you will be able to get here, to the users who are really indifferent to those things, but where we have reach and coverage and capability that might not be available from others.
Thank you for explaining that. Tom Greer wants you to explain a little bit more when you say orbital rights. Do you have something proprietary as far as geographic location in space?
That's a great question. They're all great questions, but this is one that keeps coming up. I did an interview with the international business editor of the Financial Times on Monday where we talked about this, and she used the term rights of way and in her question. So think about it like this. Not all low Earth orbit is equal, okay? So low Earth orbit can be 100 kilometers above the planet, 160 kilometers above the planet, 300, 350. So there are all of these bands of low Earth orbit. We're at the upper end of those bands. So there's a lot of busy traffic down there in the low slots. Our application was one of the very first ever to be made. And the German engineers that conceptualized this network deliberately selected 1,050 kilometers because there's less clutter there. There isn't junk flying around. It's nice, clean space real estate. And then you've got these, remember I talked about the polar orbits going from the North Pole down to the South Pole and back up again. All of those satellites at 1,050 kilometers in that range are crisscrossing across the same sort of zone of control, if you will, above the North Pole and above the South Pole. So it's like, think about throwing tennis balls through a window or through a door, right? You've got to time how you're throwing them through so they're all going through and going into their various orbits. That's a real estate point to the questioner's point. That's and well recognized. At 1,050 kilometers, and I think about this from a terrestrial standpoint where I came from, terrestrial wireless. It's like being on top of the hill, okay? At 1,050 kilometers, you're on top of the hill. You can see a lot more from up there, and everything else is in LEO is below you. Now, remember, if you're on top of the hill and you've got the #1 priority access right to that Ka band, now you're on top of the hill. Now you can see down and see everything else that's below you, and you've got the priority to that Ka band. That mixture of priority and position really gets to matter. Then polar orbits are, in our view, much more useful than elliptical orbits. And I'm not going to name the other constellations that have mostly elliptical orbits. And that's an orbit where you're going diagonally around the planet instead of going from north to south. The elliptical orbits that were being applied for was, well, because that's where most people live on the planet, which is true. They're in there sort of the bit around the middle and a bit north and south of it. But above northern and southern parallels of a certain mark, you have to have polar orbits to be able to provide coverage. And enterprise customers and governments all want coverage in those zones. It becomes a big differentiator. So I would say we've got the trio combination. This is the three cards of the 1,050 kilometer slots, polar orbits, priority access to Ka band. So it's a great question, and I like giving the answer. But yes, it does matter, and I think it matters a lot.
Thank you for explaining that, Declan. That was very helpful, I'm sure, for many of our viewers. Question from Rob Ansalo. So what is the cost of your technology versus the traditional communications methods? And what hardware is required by the consumer to adapt your technology?
So this is not a consumer offering. The people that the enterprises and small businesses that will be using our services will use those to create consumer services. We're not trying to disaggregate and get direct to the consumer. We are serving enterprises. We're serving businesses. Now, the size of the businesses is going to be much smaller in many cases than traditional enterprises, but we're going to be doing the big guys and the governments as well. But it will be those local entrepreneurs that will be providing the consumer services to your handset here. And it could be traditional carriers. I won't name them because we're speaking to some in different parts of the world now, but traditional mobile carriers recognize that this is a capability that they need and are going to need. So we will provide that capability to them. They will then turn it into a terrestrial consumer offering to offer to their consumer customers. We are not like Starlink or like Kuiper trying to get direct to consumer revenues. That's not our target market. There was a second part of that question. I forgot what it was.
Yes, it was. I think it was deleted in here. So let me find that in a second.
Okay, sorry. If I think of it, I'll come back to it.
Yeah, and I'll find it in just a moment. A question from RF. Does Rivada have assigned frequencies for their 300 satellite constellation?
Yeah, no, this is the whole point. With the Ka band, well, the Ka band is shared. So it's not that you've got this much of it it's shared, meaning you get access to all of that Ka band that's allocated for LEO, but and this is why the priority matters, right? Where you rank in priority to have access rights to that Ka band shared spectrum. It's not like terrestrial spectrum where you are given this much from X to Y megahertz. That's your band, and that's exclusively yours. That's not exclusive. It's shared. That's why priority matters. So yes, it's all of the Ka band for commercial LEOsat. Now, there's another part of the Ka band that's dedicated to military use, but for commercial use, that's all shared and all accessible.
And Bernd Lowe asks, when does Rivada intend to complete the awarding of orders to key system and module suppliers?
Great question, Bernd. We have selected Terran Orbital. That's a question you now need to ask them. They're responsible for delivering an integrated satellite to us, and ultimately, so we have sourced the decision making. Now it's an iterative process, of course, but we've sourced that decision making to Terran Orbital in terms of, for example, which lasers are we going to use? Those sorts of questions that Bernd, I imagine, is thinking about. Those are Terran Orbital's decisions. Things like launch, for example, ground segment. Those are all things that Rivada is doing ourselves. But I imagine Bernd's question relates to the satellite in-space component.
And another question from Bernd asking, will Rivada use lasers for inter-satellite communications, and how many terminals per satellite?
Yes, absolutely. That's kind of part of the secret sauce. So maybe you weren't on for the first part of the call, but the whole, I called it like, imagine a fishnet cast around the whole planet, where each of the strings of the fishnet is a laser. So every satellite will have a minimum of 4 lasers, 4 independent lasers connecting to, and each one of them will be connected to a separate adjacent satellite in the constellation. So it's a minimum of 4 per satellite, and we're putting up 25 satellites, so 24 operating, 1 spare per orbital plane, and we have 24 orbital planes, so approximately 600 satellites, each one having a minimum of 4 laser connectors on it. So you can do the math on that, Bernd.
And Declan, we can end with this question due to time. Paula Mathis wants to know, what is the timeline to deployment? And also, if you can give us some milestones that are coming up with some dates.
Great name, Paula Mathis. I like that one. The timelines to deployment are our first launch of the commercial. We're doing a precursor launch next year. We're doing 2 precursor launches next year, but 2025 is when the main constellation goes up, and our first launch is out of Vandenberg, California, in April of 2025, and then we've got 12 heavy launches scheduled over the next year to get the year from April 2025 through to getting the first 300 satellites up and running. And then after we get those deployed, we then move immediately to getting our second 300 satellites up and deployed. And that's another satellite procurement RFP, by the way, that we will be doing. But one thing basically goes straight into the other. So April 2025, the commercial constellation starts being launched.
That'll be here before we know it.
Yeah.
Wow, wonderful. Declan, thank you so much for this thorough presentation. We really enjoyed it, and we would love to have you back in the future with some updates.
Pleasure, Anna. Thank you very much.
All right, everyone, stay with us. We'll be right back with our next presenter.